Welcome back, ladies and gentlemen, to another rendition of Chapter 5, and we talk about now congruent polygons. The goal of this whole chapter, or this section I should say, is to identify and use corresponding parts to find missing sides and angles. Now we're going to be talking about more than just triangles today. I know last videos I told you it was all be about triangles, but we're getting there. The opening question I have for you is to think about this. What physically makes two figures congruent to each other? Let me say that again. What physically makes two figures congruent to each other? Whether the two figures are triangles, quadrilaterals, pentagon, hexagons, octagons, whatever the figure is, what makes two figures congruent to each other? That's the question we're going to answer in this video. Today, in order to be successful, you're going to have to be able to identify corresponding parts of polygons and kind of answer that question that I just said. In later videos, we'll talk about the mathematical statements about proof, and then we'll dive into, of course, using parts to find some missing sides and angles. So let's go back to that question that I said. What physically makes two figures congruent to one another? Well, what makes figures congruent to one another is when all of their corresponding parts are congruent. Why is that important? Because when the corresponding parts are congruent to each other, I can perform, here's our word again, a rigid motion or multiple rigid motions to map one onto the other. Let me explain. Let's say, for instance, I have myself a triangle. Okay, I have myself a triangle here. And I want to go ahead, and I'm going to go ahead and duplicate and copy this exactly as so. So, as long as I can do some kind of slide, rotation, a flip for a reflection, as long as I can do one of those rigid motions or multiple rigid motions to fit this perfectly on to the other, clearly as I can here, that means that we have congruent figures, because all of the corresponding angles here, and here, versus here and here, all the corresponding angles are congruent, and all of the corresponding sides are congruent as well too. And that's exactly what you see in this diagram. You can identify which ones are congruent to one another based on the matching tick marks and the matching arcs for the angles. And notice what we have here is order. Order matters, order matters, order matters. What we'd see here, guys, is see what happens. Triangle DEF and triangle ABC. Where do they match on up? D matches with A, hence why A and D are congruent. E matches with B, that's why E and B are congruent to each other. F matches with C, that's why they have two arcs and they have two arcs there as well. Order matters. In conclusion, if all the corresponding parts of two triangles are congruent, then two triangles are congruent. Or vice versa. If two triangles are congruent, then all the corresponding parts are congruent. So, both, all right, the if, all right, as our conditional statement is true, and our converse is true as well. So we're going to do one quick example of writing what we call a congruency statement. So it says write a congruent statement for the triangles and identify all pairs of congruent corresponding parts. What's a congruency statement? Simply put, it's a statement that's got a congruency symbol in it. It's super basic. So let's talk about the two triangles. The two triangles are congruent. So triangle JKL is congruent to what triangle? Remember what I said? Order matters. I'm going to say it again. Order matters. Oh, you didn't hear me. Order matters. So I went JKL. So I went 2 arcs, 3 arcs, 1 arc. I got to go in the same order. 2 arcs, 3 arcs, and 1 arc. That's going to identify which order we continue in. And then it says, when all corresponding parts of two triangles are congruent, then you show the triangles are congruent. So we've shown the triangles are congruent. Now let's go to each of the individual matching parts. Well, what do we notice? L matches with R, right? L with R. So angle L is congruent to angle R. Angle J is congruent to angle T, and angle K is congruent to angle S. Order matters once again. Now what about all the sides? JK, segment JK is congruent to what side? I went from J to K. JK matches with TS. Notice the order. Now I have LK. Well, what order did I go in? I went LK, so that's RS. And lastly, I'm going to my last one. I just did LK and RS, so my last one is JL. So if I go JL, that is TR. And that, ladies and gentlemen, is our congruency statements.